Hello, everyone. Thanks for coming. My name is Aki Rodic, and I'm going to be talking about making WebGL tools with Polymer. You might have heard that I'm coming here from Google, but actually I joined a different company a couple of months ago. It's called Refactoring, and we are creating new tools for the building industry using web technologies and WebGL. Before I start, I would just like to get some sense of how familiar you are with this topic. So how many of you have had experience with WebGL frameworks such as 3.js? Can you raise your hand? Oh, all right, that's quite a bit. How about using web components technologies and Polymer? All right, that's pretty good. But I assumed you've heard of Polymer and web components, right? All right, that's good. That's good. Also, has any one of you ever used any 3D modeling package like Maya, Cinema 4D, or are you familiar with After Effects, like any sort of creative tool? All right, that's the right crowd then. All right, so just to give you a little bit of my background, I've been doing computer graphics in various form for many years already. I kind of started as a 3D modeler / animator. I've done a lot of motion graphics, and somehow I got into the game industry, where I worked mostly as a technical director, kind of helping engineers and artists to work together by building tools to help them work with other tools. At the same time, web development was kind of my hobby. And over time, when WebGL came out, I kind of got really hooked into it and started building tools for real-time 3D graphics on the web. So right now, I'm at this spot where I'm basically using web to build creative tools for other people to use. In this presentation, I'm going to show a couple of demos, and for our WebGL needs, I'm going to use a 3.js framework. But all of the concepts and ideas I'm going to show here are actually applicable to any other WebGL framework. They're pretty abstract. Also, we're going to use Polymer for our web components needs, and there are many other alternatives as well, like X tags, I think bricks or something like that. And also all the custom elements we build are essentially just HTML elements that can work with any other HTML elements. So the use of polymers here is not necessary, but is definitely recommended. It's a great library. So first and foremost, I would like to say something about native tools. I love all the native tools that are available. I've used Maya for many years, some amazing tools like Side Effects, Houdini, After Effects. They're really, it's amazing what is possible with them. They're highly sophisticated. The amount of engineering and creativity that went into developing them is just simply amazing. But those same tools suffer from some problems that are just inherent to the native platform. Just to name a few, for example, in order to run a tool, you actually have to download the whole tool and install it on your machine. That's acceptable, but it's definitely not ideal. And then if you want to work on a different machine, you have to do the same process again. And let's say you want to share your work with someone, you can't just send them the work. They actually have to install the same tool to actually ingest that content. And I think in today's world of cloud computing, that's definitely not ideal. So I think we can in the future we can make much better tools that are kind of built natively on the web and have collaboration built right into the tool itself. So how can we do that? You might have tried to build a very complex application on the web, and the experience that it's really difficult. Web technologies just was not built to scale, and you will run into a lot of problems once you start growing your complexity over time. But fortunately, web technologies evolved, to face those challenges. And today we have some amazing technologies, such as web components, ability to do automatic templating, data binding, and defining your custom elements and so on. I've been working with these technologies specifically to make WebGL tools for the past couple of months, or perhaps even a year. And I love it. It's so much fun. It's just amazing how much complexity gets out of the way once you start encapsulating really complex applications into the elements, and then using those, various APIs you can expose to make elements talk to each other. It's really fun. So there are already plenty of web tools for computer graphics being developed right now. These are just some of them on this list. And I'm sure most of them are facing some of those scalability challenges right now. I talked to most of the founders of these companies, and we discussed how they're facing those challenges. And it's interesting, some of them, like Lagoa.com, actually decided to completely ditch HTML and build their UI framework in WebGL. So they're building their menu systems, all their buttons and whatnot, entirely in WebGL, which is, it tells you kind of how much difficult it is to build scalable apps in HTML, since people have to do that sort of stuff to work around it. But I think there's a better way. I think web components are definitely the answer, and this presentation will be a demonstration of some of the concepts you can use. So we're going to start putting some web components together to build a 3D interactive application. And for that purpose, we're going to use 2 bundles of custom elements that I've recently published. One of them is called IO bundle, which is a collection of kind of general purpose user interface elements that you can data bind to different data types and fiddle with the data interactively. And the other one is a 3- bundle, which is a set of custom elements specifically designed for 3JS API. Here is an example. Let me zoom in a little bit. This is what a custom element could look like for a 3JS application that acts as an interactive viewport. So you basically just insert this into your application. You call it, you declare your element 3-viewport. You set up some attributes such as camera, grid orientation, clear color, and whatnot, and it simply works. And here it is. This is a live application. You can zoom in and out, move the camera, and I'm not sure why I'm not seeing the cursor, so I'm going to get out of the presentation mode. So let's say I want to change the camera. I can just type in a different attribute and say I want to have a top camera here, and the camera simply changes. So there's a lot of complexity hidden inside of these components. This specific component has, the rendering render embedded inside of it. It has all these helpers for the grid, for camera controls and so on. But you, as a developer, don't have to really think of it. If you just need this sort of viewport where you can fiddle with your 3D scene, this is all you need to know. Just insert your element, put your scene to the attribute, and that's it. Here is what a markup could look like for your 3D app that uses 3-viewport. Yeah. Yeah, I will. They're definitely available. I already tweeted it a couple of hours ago, so I'll tweet it again. Yeah, I'll show it. So yeah, in theory, you can just write your 3JS app the same way you're doing it already. Just use a script block. Define your objects, your scene, and animation and whatnot, and then you can take your scene and just assign it to the attribute of 3-viewport. However, I found that it's really convenient to actually wrap your application into a custom element itself. So in this example, I have an application called main-app or app-main. And I'm simply using a mustache data binding expression to bind the scene of my application to the viewport. And this is how it looks live. So this is a very simple application, just loads a 3D scene, and I can move around, and that's pretty much it. So what's really nice about this approach is that now that you have encapsulated viewport functionality and your application in another element, you can scale this really easy. So let's say you want to have 4 viewports for different cameras. We can just, create 4 instances of 3 viewports, set a different camera for each one, and change the grid orientation. And here it is. It's rendering in 3 different orthographic views, and also the perspective view. So there's one trick that is implemented in 3-viewport to make this possible. If you're intimately familiar with WebGL and 3.js, you probably know that you cannot simply render into multiple viewports because you only have one GL context. And if you create 2 canvases with 2 different GL contexts, the API is not really built in such a way that you can easily manipulate data in multiple contexts. So what's happening in here is that the viewport itself implements a 3.js renderer, and the renderer can change the hosts once a render call is requested. And what you're seeing here is only one of these viewports actually contains the GL context. The other 3 have a canvas 2D with just a texture that is copied from the last rendered image of 3D context. So there's a lot of complexity built into this viewport that makes this possible. But again, for you as a developer, that doesn't really matter. You just use your viewports, and you can render to as many viewports as you want, and you can put them anywhere on your page. So once we have our viewports ready, let's check out this other component. It's called the 3-outliner. It's a very basic UI element that pretty much any 3D application has. It gives you a kind of textual representation of your scene graph, where you can easily fiddle with the hierarchy of your scene. So here, you can see the API is also very simple. I declare 3-outliner, and I set the attribute scene to scene object. And this view below is automatically generated. I can collapse, if I find my cursor. I can collapse hierarchy. I can also toggle the visibility buttons. And yeah, this is all automatic, so you don't really have to do. All you have to do is just assign the scene attribute. This is a closer look at one of the elements that's nested inside of the 3-outliner. It's a 3-outliner item element, which has an object attribute, and it automatically generates this collapse button, visibility button. It assigns the icon based on which object type it is, and it gives you a little label for the object's name. Right, it's very convenient. And this is how, this is looking in the insides of the 3-outliner. This is kind of a simplified version of what the element is. So in the upper block, you see the 3-outliner itself. It's basically using Polymer's recursive template to generate as many instances of 3-outliner item elements as it is necessary. So let's say you give it you give it a scene object. Scene has its children array, and the template would iterate through that children array and create an outliner item for each child, and then it will dig into the children of every child and keep repeating this template over and over again until the whole outliner structure is completed. So it's a very simple concept, but very powerful. And below you see the kind of the crucial 4 lines of the 3-outliner item block, which basically gives you 2 toggleable icons for expand, collapse, visibility, and then there's a label, and so on. So very little code to create something that's very useful for exploring 3D scenes. So to add it to your app, you simply add it to your markup. You bind the scene to the outliner, and there you go. It's added. Now we can add some responsiveness to it by using some of the Polymer's elements, like core drawer panel. We simply embed our elements into it, and this is how it works. So once I start resizing, once I pass a certain threshold, the drawers hide on the sides, and then if I want it back, I just kind of like slide from the right or slide from the left to expose each drawer. Ideally, there would be a button to do this, but it illustrates the point. So now, once we have our outliner, the final element we're going to put in is this IO inspector object. This element is actually part of the IO bundle, and it creates a kind of like automatically generated view of JavaScript objects. It can be a 3JS object. It can be any object you give it. And it basically creates a list of all the properties on the object and gives you an appropriate view for its value for you to manipulate. So for example, here I have a scene object. I can expand children and see that it's an array with three elements. And I can keep expanding. Or I can also click on the key link of each property, and it basically gets me one level into that object. And I can keep going in and kind of dig deeper and deeper into this object structure. And there's the back button that lets me go back. So this is not the prettiest looking interface, but it is extremely simple and extremely powerful because you can literally give it any object and it will just generate a view for you. Once we add this to our scene, it looks like this. On the left, we have the outliner, and on the right, we have some sort of a property inspector. So it would be really nice if we can now have interactivity in such a way that when we click on each object on the left, the inspector on the right actually shows us the properties for that object. So the way we do this is by listening to certain events and then performing an action to depending on the event. And it happens that the 3 outliner item has a clickable label which emits an event called 3labelClicked. And with that event, we get a payload that represents the object that is being clicked. So what we can do is listen to that event, and once we get it, we set the inspector.value attribute to whatever that model is that is being clicked. And this is how that looks in action. So I can click on this wall, and you can see that on the right, the properties are being updated. I can also, for example, click on this no name light, which is unnamed, and I should be able to click. Well, let's select one with the name. And I can just change the name, and you can see on the left, the name updates automatically. So this is part of that Polymer data binding magic that just happens automatically. You don't really have to do it yourself. You can also, toggle visibility. You can, move stuff around. Let's say expand position. You can move X and Y, and so on. All right, and last but not least, let's add some menus, because every complex application needs menus, and it needs lots of menus. And I've been trying to do this for quite a long time, and I find out that menus can really be a pain in the ass, especially when you're building them with markup and CSS. And to get, it took me a while to build a component that actually creates a very easy to use menu that's also very customizable and has a really nice user experience. So this is probably one of the most interesting elements that I published. It has a very nice API for you to set up all the properties for the menu. For example, right now, menu is vertically oriented. I can make it horizontal just by toggling the horizontal attribute. It doesn't expand automatically. It requires click to expand. So I can change that by modifying auto expand attribute to true, and now it just changes automatically. One annoying thing about menus is that if you implement your hover states in CSS, you need to be very precise when moving to the submenus, because you can accidentally trigger the next element and kind of like move to a different submenu, the one that you didn't want to go. So here, instead of using CSS, I implemented a custom hid testing algorithm that uses your mouse's velocity to determine how to switch menu items. So if you're like moving up and down, menu changes very rapidly. But if you're kind of like moving diagonally to your submenu, it will kind of wait a little bit to figure out if you're going to the submenu or not. And the API to setting for setting menu items is very simple. It's basically just a JavaScript objects with a bunch of arrays and objects that can also have sub options and so on. So basically, when you create a menu, this is how you define it. And here it is, added to the application. It doesn't have any functionality. It's just kind of like a stand-in to show what a menu could look like and how simple it could be implemented. The final application is, I would lie if I say the application is 5 lines of HTML, because it's obviously a lot more. But in certain sense, it is 5 lines of HTML. Like, this is the application that I just put together. This is all it is. There's a menu. There's actually the main application that contains the scene loading. There's the menu, the outliner, viewport, and inspector. There are like 4 elements that all expose very simple APIs that you can hook up together, and they just work. So from my experience working with Polymer, a couple of things I've learned is that it's much better to design your elements for general purpose. Initially, I started making all these elements for 3JS API specifically, and over like several stages of refactoring, I found out that most of the things I implemented are just poorly designed because I made decisions around the 3JS API, not about like kind of like a general purpose strategy. So I would definitely encourage you, whatever you design with Polymer, like think about like how you could use any element like outside of the context that you're developing for. Also, there's a neat little tool called core signals in Polymer, which lets you connect elements at any part of hierarchy and in a very like explicit way. And sometimes it may seem like a very like nice shortcut to get elements work together, but I would definitely avoid using it because once you like start hooking things with the core signals, it can get like pretty messy, and you get in this like spaghetti code, and that's not nice. And also keep refactoring. Like like whatever you're doing, you're probably doing it wrong. So you should do it again because it will be better. All right, so that's all I had to say. Thank you very much for your attention, and we are hiring, so check out flux.io/join us, and also I'm open to any questions you might have. Also, presentation is tweeted, so if you go to my Twitter handle, you can find it there. Yeah. Yeah, so the question is, when I made the 3JS components like the outliner, like this one, did I first create the atomic components and then the whole thing or not? So initially I created the whole thing, and then I identified the parts that I can extract out and make it usable to other components. And then over like several phases of refactoring, I split it in 3 components. So the top component here is 3-outliner. It contains this component called 3-outliner-item. And then 3-outliner-item has another component called 3-label, which is basically I can't find my cursor. It's this icon and the object name label. So the 3- label is useful in many other contexts. It gives you like an icon automatically. It gives you like a name that, if you set the attribute to editable, you can actually edit the name right there in the label. I can reuse that in many other components. But that's kind of like the process that I went through. Yeah.
Is there any reason why you wouldn't be able to make custom directives in Angular like this?
No, there's no reason. Angular could do this with directives as well. Yeah. Okay. Yeah. All right. No more questions? All right, thanks a lot. Oh, one more. Oh, performance. That's a good question. As you may know, web components are, it's not one technology, it's a bunch of technologies. Most of them are ratified or in the process of being ratified. If you use a Chrome stable, I think almost all of the features will run natively and they will be extremely fast. Some of them might be polyfilled. If you're running Canary, most certainly all of them are running at the native speeds, so it's extremely fast. Running in other non-Chrome browsers, though, can be pretty slow, depending on which features you're using. I would expect those browsers to catch up and get faster in the next couple of months to a year. But for now, web components are still kind of like an exotic new thing that it's not going to run super fast everywhere. But this application actually runs on my tablet. This whole presentation, actually I don't know about the screen size, but yeah, it runs on my Android and it's reasonably fast. All right, thanks.